Have you ever wondered how computers communicate with each other? They use a special language called network protocol, and today we'll break down how protocols work in the simplest possible manner. So let's get to it. Hello everyone, welcome to Building Block Dev, your go-to place for simplifying tech concepts. My name is Oyinbo David, and today we are going to be talking about the network protocol. Don't worry, we are going to keep it as simple as possible. So let's get into it. So what exactly are network protocols? You can think of them as some set of rules that different computers will have to follow so that they can communicate with each other. Just the same way we follow grammar rules in order to communicate using a language between each other. Computers use protocols to communicate with each other so that they can send and receive data. So there are different types of protocol. We have the TCP, we have the IP, UDP, and lots more. But in this video, we are mainly going to be talking about the IP, that's the Internet Protocol, as it is the basis for many other protocols. So it is paramount for us to understand what the IP is. The Internet Protocol IP is a layer 3 protocol, meaning it's a network layer protocol. The network layer is responsible for facilitating data transfer between computers on different networks. That's very important, on different networks, because when you're on the same network, you don't need the network layer for transmission of data. The network layer also finds the best physical path for your data to pass through. The Internet Protocol is a protocol set of rules for routing and addressing pieces of data so that they can travel across network and get to their correct destination. And meanwhile, when data is traveling through some network, it is usually divided into smaller pieces called packets. And these packets carry the IP information, things like the source address, the destination address, etc. We are going to go deep into that in a minute. Once the packet gets to their destination, they are handled differently depending on the kind of transport protocol that is used in combination with the IP. Common transport protocols are the TCP and the UDP. So let's talk a little about the IP packets. The IP packet is divided into two sections. We have the IP header and the data section. And this is the diagram of what the IP header looks like. So it has some crucial information. For instance, the version, the total length of the IP packets, the options, the TTL, and so on. So let's pick them one by one. Okay, as you can see from this diagram, each column represents 1 bit, and a set of 8 bits is 1 byte. Then each row contains 32 bits or 4 bytes. So there are some crucial information here that we can check to help us understand how the IP packet is routed through the network. For instance, the version. Currently, the version can only be 4 or 6, and since we are looking into the version for an IPv4, a version 4, this value will always be 4. Then the IHL, which is the Internet Header Length, is the number of rows that we are going to have in the header. As you can see, the options section is variable, so there's a possibility that you might not even have an option, and many routers actually disable using options completely. So the minimum length for the IHL is 5 and the maximum is 15, given that we have 4 bytes that we can fit into this particular section. Another crucial information that we can get from this IP packet is the total length of the IP packet itself. So this total length is the length in bytes of the IP packet. We can fit in 16 bits into this header property, meaning we can have up to 65,000 bytes. That's the IP packet itself can be up to 65,000 bytes. So there are other properties to consider, for instance, the identification, the flags, and the fragment offset. Okay, let me use this to explain how fragmentation works. When data comes to a network router, for instance, or a device, it tries to shove data or packets into what they call frames. So just imagine them as like boxes, and it processes them one after the other. The sweet spot is if your IP packet can fit into a single frame, and it's just going to take that data and shove it into a single frame. But there are instances where your IP packet is larger than a frame, so the device can specify that it can only take up to 2000 bytes, for instance. If you send it a packet that is as large as 65,000 bytes, what it does is to try to divide it and shove this value into different frames. So the identification field is basically used as an ID for each fragment. Okay, on the flag section, you can actually set if you don't want the IP packet to be fragmented at all. If you have already set it while you are sending your IP packet, once it gets to the router, for instance, and it needs to be fragmented, what happens is the router just drops it, and there's a possibility of it sending a message, an ICMP message, that okay, we cannot fragment it, so that you can do the fragmentation from your end. But there are times that the ICMP is disabled completely on the router and you will not receive anything. Yeah, and this can actually cause some issues like the TCP black hole, data black hole. So what happens during the TCP black hole is, okay, you establish a connection, like a network connection, everything seems fine, but you keep sending data, but the data doesn't reach its destination. One thing that can cause this issue is if ICMP is blocked on the router, for instance. So instead of the router telling you that okay, your fragment is too big, your IP packet is too big, it just drops the packet and leaves it, and you need to figure out a way to know that this is an issue. Okay, the next property we want to consider is the time to leave. The best way I can explain this would be using something called the hop count. So now when your IP packet is traveling through networks, it basically hops through different router basically before it gets to its destination. So if it's going from one network to the other, it will hop from one router to the next one. But what happens is, if you have a time to leave set, just imagine it's a hop count, and going from one router to the next router is a single hop. What happens is that each router would reduce the value of the time to leave, and the router that reduces it to 0 would drop that packet and send a message, an ICMP message, back to the source that's okay, we did not find the destination or time exceeded basically. So if we are going to set a hop count of like 3, for instance, once the data gets to your router reduces it to 2, then it sends it to the next router, which reduces it to 1 and sends it to the next one. So the moment it gets to this next one, it has not gotten to its destination yet, this next router is going to reduce it to 0, and it will say that, oh, okay, you don't have any other time to leave. So it drops this packet and sends a message back to the source. Another field that is important in this IP header is the protocol, and there's a list of protocols that you can actually put inside this header. You have the TCP, the UDP. There are lots of protocols that you can put this. So the value that you put here is dependent on the kind of protocol that you're using. And also, very importantly, in your IP header, you have your source address and your destination address. So it's very important. These values are very important because once you send data from one computer to the next computer, it puts its own IP address and the IP address of where it wants to take it to. So when it gets to the destination also knows where the data is coming from, should in case it wants to send back data. And also note that on this level, there is no notion of having different ports like you have when you are doing when you are using the UDP, for instance. But then we are going to discuss the UDP in a separate video completely. But this is the anatomy of the IP packet. You also have the chance of adding several options to your IP header, but many routers tend to disable this option, so you tend not to use it so much. But to understand the general overview of how the IP packet traverses the different network, these are the values that we've discussed before. That's the source and the destination addresses, the time to leave, the IHL, the total length of the package. Those are the properties that you really need to understand. I hope this has given you a better understanding of what the internet protocol is. Don't forget to like this video and subscribe, and also click on notification bell so that you can get a notification anytime I post a video like this. Thank you. Bye.